Hey everyone, welcome to Application Development Virtual Group webinar. My name is Sarah Huang. I'm the co-organizer of this virtual group. Join me here is Debbie Huang, our co-organizer. Today, Greg Heier will present Introduction to Google Cloud Platform, GCP. Greg Heier is a director at Onyx, a cloud solutions provider and one of Google's premier enterprise partners. Greg has over 10 years of experience with cloud architecture, infrastructure, and big data. He is a cloud evangelist and has presented at Google events across North America. We really appreciate Greg shares his knowledge of GCP with us on a Saturday night. Let me first take care of some housekeeping stuff of past community, then I'll transfer screen over to Greg. Past Summit 2019 has announced the session schedules. If you register by September 13th, you'll be able to secure your place before the registration price increases. As a member of our application development virtual group, you can save $150 of your conference registration fee. And to access your discount, please use the code VGDISHX2H when you register, and your savings will be calculated at the time of your registration. And this is how you may secure a spot. You may compete for speaking spot at Past Summit 2020 by attending the speaker idol at Past Summit 2019. And you can learn more by going to the past.org Summit 2019 to register. And Past has announced the 2019 Passion Award nominations. Now it's open, and the nominations will be accepted until September 15th. And these are the past stuff you can pre-order and pick up at Past Summit. And these are the upcoming virtual group webinars. We have, this is our current one, and then there are a bunch of webinars from Cloud Virtual Group, as well as DBA Fundamentals, high availability and disaster recovery. And then we have another one in September, which is Introduction to Power Apps and Flow by Charles Sterling from Microsoft. And there's some more from Women's in Technology, from DBA Fundamentals and Cloud. These are the current past virtual groups. You may join as many as you would like, and the past membership is completely free. And as always, if you are not a member of our virtual group, you're more than welcome to join us. This is our virtual group, Application Development. And these are the upcoming SQL Saturdays, and you can go to the website to find, to get more detailed information about it. And PASS has a career center for job hunters as well as the employers. You can, as an employer, you can post your jobs over there, and job hunters, you can go there and check them out to view jobs. this is how you may connect with the past through Facebook, Twitter, LinkedIn, or Instagram. And this is how you may ask questions during our webinar. You may click this little hand sign, so you can, one of either me or Debbie will unmute you so you can interact with, ask your questions directly interact with Greg. Or you may enter your question at the chat window, then I'll read your questions to Greg. That's all I have. And let me transfer screen over to Greg. And thank you so much, Greg, to present for us.
Well, thank you, Sarah, for that nice introduction. And just let me know that you can see this full screen okay?
Yeah, I can see your screen.
All right. So thank you, everyone. My name is Greg Heier. I'm the Director of Partnerships at Onyx. And so I will talk, this is an introduction to Google Cloud Platform. And this is a huge topic, right? We can't possibly touch on every single thing that's in Google Cloud. But I want to give people an overview, and especially some of the services that it does offer. I understand this is a developer group, so I'll try and focus on some of the ones that might be really interesting to developers. But I think it's also really important to have an overview of what the cloud, specifically what Google's place is in the ecosystem, and what are they targeting? What are they trying to do to solve some of the business problems that are out there? So we'll start by looking at the public cloud landscape. I'll talk a little bit about Google Cloud's differentiators. So there's a ton of choice right now when you look at where to run applications. You've got on-prem, plus you've got a bunch of different public clouds as well. So look at what makes Google Cloud different. Why would I choose Google Cloud, or what might be one thing that I would say is different about it from the other clouds? I'll show you a little bit about how to get started. And then we're going to spend a lot of time on what the services actually are. So the infrastructure, which Google refers to as compute, storage, database and analytics, and machine learning. And the reason why I want to really look at those services is until you really understand and can see sort of the breadth of services that they offer, it's hard to know how you would architect an application. So if I just said, oh, go build an application on GCP, you might start by choosing the wrong services or just one that wasn't ideal, and you didn't realize that, oh, hey, over here, there's actually a service that does exactly what you want, and you can use Python, and you can use the, all the modules that you want, and that sort of thing. So it's really important to understand all the different things that it can do, so that when you architect, you actually have a full picture and can make the best application possible. So just a real quick thing on Onyx and who we are, where I'm from. So I've been with Onyx about 10 years now, and we've been a Google Cloud Enterprise partner since 2002. So a long time, all the way back when the only thing that you could buy from Google was a Google Search Appliance, which is a physical server that sits there. Well, they've come a long way since then. We're a 3-time North American Partner of the Year, and we are a premier partner, as Sarah mentioned. And we really work across the entire spectrum of Google products. So we're going to talk specifically about Google Cloud Platform today, out of all the different services that they have to offer. And what we really do is we are a solutions provider. So we will look at a business use case and say, hey, I need to do this in the cloud. I need to ingest a ton of information and store it in the cloud and then get that out to my customers, whatever it is. And we'll architect the solution and deploy it for them. So that's really our specialty. So the public cloud landscape. And it starts with this pretty basic question. Why are enterprises moving to the cloud? As we know, everybody had on-prem systems, and the bigger these companies got, they just started building their own infrastructure, more servers. They had whole buildings dedicated to their own servers. Many companies still do. But they're noticing something, and that is that the servers are getting old, and they're going to have to modernize them. So that's often a factor for saying, oh, I think I should look at the cloud for actually doing this now because my infrastructure is getting old. Also, they want to re-architect those applications so that they become what is referred to as modernizing, or creating a modern application. So this would be things like using Kubernetes, using containers, making those applications auto scale so that you're not just bound to the RAM or the hardware of a server, but you can actually auto scale in a cloud environment. So that's a huge driver, especially on the application side, where, man, developers have been really pinned into whatever infrastructure they had. And infrastructure was a decision driver. Well, that's no longer the case. Now you can just build your application, and if it gets popular, great, we can auto scale it using these cloud services. Better data management. So again, another thing that would prevent applications from being successful as they scaled was, oh, our database is now so slow, we have to migrate, we can't even use SQL anymore, it's gotten so huge, or whatever the case, or we have to build a brand new cluster and that's going to cost $1 million. So the idea of having this very modular data management is another reason you see the move. Rapid application development, being able to split up the different pieces of development, which you'll hear about today. Smart business analytics and AI. So the promise of AI has been out there. I'll talk a little bit about that for sure. I won't hard sell you on it per se, because if you've really done AI development, you understand that it's definitely still in its infancy. But I'll talk about the different, where there are use cases for AI that are really good, but then there's use cases that aren't so good, at least right now. And what I mean by that is that the tools just don't exist for it yet. So what all these cloud providers are doing is they're trying to build the tools that will enable better AI in the cloud. And that is exciting, because we're starting to see some of them finally come to light. And then finally, increase productivity and collaboration. So just the ability to have more workers connected. The cloud, if you've got global workforce, it really provides for everything from, great email services to shared folders and files, down to, chat and real-time video, that sort of thing. But here's the bottom line: cloud equals choice. And this is definitely true on the developer side. So it can mean a larger choice of languages that you can use, a larger choice of modules and resources that you can include in your project, more memory, more storage, easier access to real-time analytics, all those kinds of things. Cloud is going to give you that choice that you probably didn't have when you were just on-prem and you were very limited to whatever your company resources were. So take a step back in time here to 2014. So this was 5 years ago. And many people may be under the impression that this is actually the way that this still looks today, right? So this was the major cloud players, and the way I define that is just, I looked at this is the Gartner Magic Quadrant for infrastructure as a service. So as you can see, Amazon Web Services at the top, no surprise there. Microsoft had a really strong game. They brought a lot of their customers over, because they had the native Azure services. And then you just see a whole heck of a lot of challengers in here, right? Everything from Rackspace to GoGrid to Verizon, and oh, here's Google. They're hanging out here somewhere. And this was a very crowded space where a lot of people were doing a lot of different things in the cloud. So that was 5 years ago. So fast forward to 2019. Things have shaken out. A lot of those players have either said, well, we're not going to do infrastructure as a service anymore, or they got bought up. The number of cloud players that are at this level is shrinking. And Google has actually moved into the leaders quadrant, where they've been for the last few years. So I think it's important for people to look at Google and say that there really are three major players in cloud when it comes to the services across the board. And it's really AWS, Microsoft, and Google. So let's take a look at some of their differentiators. So one of the biggest ones is Google has 9 different 1 billion user products. So unlike some of these other clouds where they constructed the cloud out of a client server model, So it used to be, oh, I could rent a server in, let's say, Atlanta. And later they said, well, we're going to kind of redesign this instead of just having one server, because what if that server goes down? We'll redesign this over time so that you have redundancy maybe in California. In case this one goes down, it'll fail over to this one. But it was still built on a very traditional client server model. Google didn't do that. Google, because at first they were an application company, and in many ways they still are. So they built Google Search, right, this one at the very top, and they said, geez, how can we scale this? We're going to have to build something crazy to be able to do this. So they started building a cloud network that was very native. The way that YouTube and Gmail works right now is with containers. It's kind of a lot of the technologies that Google invented to run their own stuff are the same things that you get to use. And it's actually things that they've open sourced today. So even if you use AWS or Azure, you've probably heard of Kubernetes. You've probably heard of containers. Those are things that came out of Google's problem solving with how do I make a globally scalable application when that technology didn't exist at the time. So very cloud native approach from Google. Physical security. So Google is a very new company, quote unquote, when it comes to a lot of these things. They built a lot of these just premier data centers. These are fortresses. I mean, they are virtual fortresses. They've said that some of the security rivals, any government installation, anything that you could find, they're all, private security forces. And I don't know that many companies could rival the physical security of this. So when a lot of people are looking about, well, what about, if a server gets taken or whatever, chances are that inside of your own company somewhere, there's a lot more physical security issues to worry about than inside of facilities like these. And this is one that most people aren't aware of, but Google owns their own fiber lines. And what that means is that most public clouds that are out there, they do own the data centers, but then they actually rent the fiber lines. So I mean these connectors. When you see blue and green connectors here, they rent these fiber lines from other providers. So those could be level 3 or some of those other major fiber providers out there. Google doesn't do that. They've actually laid all their own fiber lines. So every single Google data center is connected end to end, point to point with all Google fiber lines. And that gives them a tremendous amount of ability to control the entire system, security-wise, making sure latency is low, all of that stuff, and nothing else runs on it. So they can kind of make sure that each of these lines, if they need to add one, they just do it. And you can see the investments that they've made over the last 10 plus years here. The other thing that they do is something, and this is not an official term, this is my term, automatic double backups. But basically, I talked about the cloud native approach, right? Let's say I pick one. These are the current data centers in North America. The ones that are in white here are the ones that they're actually building. So they're building Las Vegas and they're building Salt Lake City. The numbers that you see are the number of zones that you have available to you. And a zone is sort of like an independently functioning piece of that data center. So Iowa has 4 different zones. So I could choose US Central, A, B, C, or D. Those are the 4 different zones that I'm putting something into. So if I wanted everything hosted in Iowa, I could do that. And I have a lot of choice around what I could do. But by default, let's say I put my data here. Google is actually going to, over time, replicate that data into 2 different backup locations that are in different data centers. So if this entire data center went down, went offline, every fiber line was cut, my data would still be perfectly fine. And maybe it would take a second for it to fail over and do that, but all the data from a reliability standpoint is actually backed up in 2 different locations. And that is actually happening in the background all the time without you doing anything. And it doesn't matter what service you're using. So whenever we talk about whether it's Compute Engine or the databases, BigQuery, that's all happening in the background. So you don't have to set that stuff up. Now you, of course, can set up your own backups in addition to this. or you want to be able to set up your own failover procedures, that's all things that you can do. But this is something that is a pretty amazing thing about what the Google infrastructure does. All right, so I'm going to jump to actually getting started with GCP. So a lot of you might say, well, this is pretty interesting. What if I just wanted to try something out? This is usually what happens at the very, very end of a presentation. I'm going to stick it in the middle so that if folks are interested, they can take a look at this. So all you have to do if you want to try out GCP is go to cloud.google.com, and you'll see a page, something like this, and just click this button. It should be a Get Started for Free. Now, if you've never used it, you'll get this ability to do this. So some accounts, depending on what account you're signed in with, you may be a business account or something that won't have this, but if it's just your personal account and you've never been on GCP, you should get this button, and it'll take you through a sign-up process. Google gives every person $300 to spend however you want on GCP. So it's kind of the trial. Hey, here's 300 bucks. Go spin up a server, go run a Kubernetes engine, do whatever you want. So once you go through the sign up process, you get your 300 credits, and you get a screen that looks something like this. This is the Google Cloud Console. Now, there are a lot of demos out there that go through the Cloud Console. There's actually a ton of them that you can find online if you want to go through something specific. I'm not actually going to go into a ton of depth on the console. And the reason is it gets incredibly dense very, very quickly. So if I started spinning up a Kubernetes engine and we had our own cluster going and all this stuff, anyone who wasn't interested in that would probably tune out very quickly. So what I will do is just show you, here's the overview of what the console looks like. And of course, once you get in, feel free to look around. This is something they created very exploratory. Basically, everything that you can do is in this left-hand menu. And a lot of the services that I'm going over, you will see and recognize in this left-hand menu. It's pretty accessible from that standpoint. But again, it can be very overwhelming when you first get in and you're just like, whoa, there's so many things to do. So instead of doing that, what I am going to do is talk about these different services and when you would use them, how they're applied to development. So remember this, cloud equals choice from earlier. If we just threw you into the console and said, okay, go build your application on GCP, here are your choices. You have so many different choices, and there are a ton of different things that you can do. And some of these almost do the exact same thing, but not quite. Just looking at the data and analytics, there are so many different options about what to do. And of course, I don't expect everybody to read all this. It is a cool cheat sheet, though, where they list all 100 plus services of GCP on a single page. So what we're actually going to do in this presentation, we are only going to be talking about these, and this will be enough. So I'm going to hit these 5 areas, and the rest of this stuff, just remember, we're only hitting 1 column out of 4. So there's even more to GCP, but I'm going to try and hit the stuff that is probably the most used and most known about parts of GCP. So this is something that we do at our company when we look at a new customer and what they want to do in the cloud. So having all those services is great. Hey, there's Kubernetes and there's data flow and there's all of these different services that are on there. But what we really need to do often in our own environments is ask some really specific questions about what we're trying to do. Because I've never had a client come to me and say, hey, what I really want to do is use Compute Engine. They just don't do it. They're not really interested in the service itself per se. What they're really interested, they might say, hey, I have a server that's on-prem today, and I want to bring it to the cloud so that I can deprecate that server. That's a business use case, and that's what we're interested in. So this is just a simple workflow that kind of goes through, do you have an existing application? Okay, yes. Are you going to refactor that? Yes. Well, then we have this, we have a package called Cloud Modernize, where we can go through and actually help you create that. And the same thing with all these different points, right? Whether or not you're going to just rehost it or just migrate that application or server, and then we have all these different options for basically how you answer that question. So it's a just something to think about, is that people are not really looking for cloud services per se. They're looking to solve problems. They're looking to solve business use case problems, and they want to know, what should I choose to do that? And that's really the importance of having a partner and somebody that really understands the whole breadth of those 100 applications that you saw in there. Okay, so let's get into some of these services though and what they actually do. So I'm calling this infrastructure, but from now on I'll refer to this as compute, because as you'll see, infrastructure has really been redefined, because typically when we talked about infrastructure, we were talking about physical servers. People would say, oh, I have, IT infrastructure, which meant physical pieces of machinery. That's becoming less and less the case. You have these services that are called serverless, where yes, they run on servers, but they don't occupy an entire server. They're split across servers. They're only using a piece of that server's memory, something like that. So they are technically referred to as serverless, where they don't have a server that you have to manage. There's no underlying operating system. There's nothing, you don't have to patch the operating system. It's just an application that's running in the cloud and managed completely. So the word compute sort of brings all of that under one banner. So maybe it is an actual physical server, or maybe it's a VM, or maybe it's a container. Those all kind of come under that compute moniker. So in compute, first one, Compute Engine. So this is similar to EC2 or the Azure servers, if you're familiar with the other clouds. These are pre-configured or fully custom VMs. So this is another differentiator, and one that Google had early on was that they have pre-configured VMs where you could say, all right, I want the big one or the medium one, the small one, but they actually have fully custom ones as well. So if you said, I want, the 800 gigabytes of RAM and this, 256 gigs of storage or whatever, you could customize each component. And when you create a VM in the interface, you will see that. You can actually say, I want a custom VM, and just go through as if you're shopping for a computer online and just pick all the components and create your VM that way. So that's pretty unique, and the number of choices they have is among the best in the industry. So this is just for creating a VM. The other things that Google has, they have what are called GPUs. Now, GPUs are technically a VM as well, but they actually run on the NVIDIA GPU hardware. So these are most commonly used for things like machine learning training. So it was sort of an odd discovery, but somebody discovered that at one point a couple years ago that graphics cards were amazing for training, because essentially it's linear algebra over and over and over. And NVIDIA has created now an entire brand out of the fact that their GPUs are not just for gaming, but they are fantastic for machine learning training. So you can actually select a type of VM that is a GPU. Now, beyond GPUs, there's actually another kind of machine learning trainer called a TPU, a Tensor Processing Unit. So what Google did is they actually took this concept of GPUs and they constructed their own hardware. This is actually proprietary hardware called a TPU, which is it looks like a regular motherboard, right? But what it does is it's specifically designed for machine learning training. And the tensor in the name refers to TensorFlow. So if you have a TensorFlow project and you want to run training on there, you can use TPUs to train incredibly quickly. So this is sort of a proprietary hardware piece where you can train just huge numbers of machine learning projects on these TPUs incredibly quickly. Now, the one drawback, they're not cheap. So GPUs start scaling up in cost very quickly, and TPUs even more so. So it's kind of like, hey, if my project is really that big and I really need results quickly, TPUs are an excellent option for that. And the final thing is per second billing. So, and these sustained use discounts. So what is that? Well, Google kind of set off this, and it's a good thing for all of us customers. They set off a war for how often billing happened. It used to be per hour. So if you spun up a VM and you only used it for 3 minutes, you would have to pay for a full hour of VMs. This was typical, say, 5 years ago. So you'd have to pay for 1 hour. Then there was per minute billing. They said, well, you would only pay for those 4 minutes. And then they upped the game again and said, okay, well, now it's per second billing. So if you only use it for 3 minutes and 2 seconds, you're only going to pay for exactly that. So this gets down to sort of infinitesimal cents at this point. But guess what? That makes a huge difference if you're a company and you have the 10,000 VMs that are spinning up and down all the time. Now all of a sudden, you're saving a ton of money through per second billing versus spending on the minute or even on the hour. And these sustained use discounts. So this is something Google does when you have a process that is going to run on a VM and you know that it's going to be running for weeks. You can actually tell the system ahead of time, hey, I'm going to be running this for a couple weeks, and you will get a discount up front. And you can get crazy discounts like 50, 60, 70% off the entire process for running it for that amount of time. So if you are going to have these sort of constant VMs up and running, you can definitely look into the sustained use discounts, because that's a great way to actually run these VMs really, really cheap. And when you do that, Google really becomes probably the cheapest cloud in most use cases because of the way that they discount for that. So that's a little bit on compute. We'll come back to some of these other ones on compute in those other areas as well. So App Engine. App Engine, totally different than Compute Engine. Sounds similar, but it's not at all. This is a fully managed serverless application platform. So if you just want to create a brand new cloud native application, this is a good potential option for you. At first, when it first launched, it only supported Java and Python. Since then, they've actually added basically every language. So they've got PHP, Node.js, and C#, .NET, all native. And you can also bring your own. So they've added the ability to bring your own framework and dependencies into App Engine and then run it that way. So it's almost similar to some of the other services that we'll look at where you can do that inside of a container. But App Engine, so App Engine is fully managed. There's no containers, so to speak. It's just the managed server platform. So you deploy the code up and then it runs the code, as a web application. Okay, Kubernetes Engine. So this was called Container Engine at one point. It's been rebranded Kubernetes Engine. And this is a managed environment for deploying containerized applications. So this has gotten a ton of press. It's one of the most popular things that we deploy for our customers. What's interesting about this is this can be a stateless or not stateless. So something that actually has external dependencies or things that you attach to it. So I could create a container, run an application with it, and then I could attach a 64 gigabyte disk and have it be running back and forth. I can even create a database inside of my cluster and run it in there. So Kubernetes Engine is sort of it has the most options of what you can do for a container. But it's still a managed environment, right? So this is different from just running if you just went out and ran your own Kubernetes cluster, you would have much, much more overhead to deal with. Kubernetes Engine is Google's managed version of that Kubernetes cluster. So Cloud Run, this is relatively new. This is actually still in beta today, but this is kind of bringing forward the promise of what these containers can really do when it comes to developers. So developers are very interested in containers. The idea that it doesn't matter if I built my application in Windows or Linux, or I built it with Python, blah, blah, blah. I just have an application, I package it up, I put it a nice little label on it and I send it up to the cloud and it reads that label and says, oh, okay, I know exactly how to run this. Boom, it's live. That's kind of like a dream, right? Every developer has wanted to get to that point where the choice then is all with the developers. They can run whatever OS, whatever languages they want. And Cloud Run is about the closest thing that we have to that. It's a managed compute platform that automatically does scaling and it automatically does these stateless containers. It uses something called Knative. And Knative is the K standing for Kubernetes, but these Kubernetes native applications. So applications that were designed specifically to run in the cloud and really specifically on these containers. So it will run these containerized apps, and you can actually run these on Kubernetes Engine, or you can run them somewhere else. So you could just say, I want to use Cloud Run, but I actually want to use my own containers or my own managed infrastructure for that. But what's really cool about Cloud Run is that, again, you create the application and then you really don't have to worry about the underlying infrastructure or anything else. You can just say, I want to run this application over here. Oh, wait, I want to take it down. Now I'm going to run it on Google Cloud Platform, and I'm going to move it over here. So the flexibility that comes with that is pretty amazing. And then finally, in compute, we have Cloud Functions. So Cloud Functions is when you want to build and deploy just a single function. And the reason this is interesting is because a lot of times when people are building their own APIs, you may have run into this as a developer. You have to sort of choose, okay, we're going to come out with API version 1.0. And in 1.0, we're going to offer 56 different functions that people can call. But then 1.1 is we're going to add 7 more functions. But when you do that, you basically have to recreate. You have to redeploy the entire thing. Cloud Functions allows you to do very, very incremental servicing. So this is true microservices. I could deploy a single function. So I might have a partner and they say, hey, I want to be able to access my data on your database. Could you enable that for me? You might build a cloud function that enables that data transfer, but that's all it does. So instead of having this monolithic application where I got to do all this stuff with firewalls and handle that just to get a single input-output in between these two servers, a cloud function is a really good way because it manages that entire thing. And it also scales it up. So if all of a sudden I'm getting thousands and thousands of hits from this company that's just hitting this function over and over, doesn't matter. It'll scale that function just like it would if it was a full-blown application. So it's a really cool way to do very small microarchitecture where it still packs all of that punch and power of a full application when it comes to scalability. So that is really it on compute. Oh, wait a minute. There's one other thing. Google's been talking about this pretty much since they launched it at Google Next this year. So this is one more thing that is a really interesting thing, and it kind of tells you also about Google's focus and where they see the cloud going. The customers that we deal with, very, very few of them have selected one single cloud. Very few of them are like, well, I'm only going to run Amazon, and that's all I'm going to run, and I will never touch the other clouds, or I'm only doing IBM, and that's it. That's incredibly rare. What's way more common is, well, we use Google for our analytics, and we use Amazon for our storage, and we use this for that. That's way more common. And what that means is those different pieces need to talk to each other. Just like you've got some things that are still on-prem, you've got some things in the cloud, they need to all talk to each other. So Anthos is sort of Google's answer to multi-cloud and on-prem orchestration. So it allows you to build these modern applications, and then similar in some ways to Cloud Run, you can choose where to deploy those. So you could say, okay, I'm going to deploy this application on site, or I'm going to deploy it into Amazon. And then 2 weeks later, you could say, okay, I think it's actually cheaper to run it on GCP. They just lowered their prices. I'm just going to take it and put it on GCP. And Anthos allows you to do all that. So it allows you to orchestrate and just move things around and move pieces around. And of course, since it's under the same program, now you're getting all the, sort of the analytics pieces, the monitoring pieces all in one place. So you could get your Microsoft, your AWS, and your GCP services all managed in a single location. And that is kind of, and there have been other applications that have done this, right? So if you've looked at orchestration tools, you know of some of these that are out there that do this type of work. Anthos is just interesting because it's a Google native product. So it's going to run on the cloud, and you're going to get a lot of that native, monitoring and all of that stuff that a cloud native application can give you. So that's really it on compute. Let's talk a little bit about storage. And this is a short section because storage is kind of, as some people like to say, well, storage is storage. And that's probably oversimplifying it, but it is a little bit true that there's less, I would say there's less focus on innovation when it comes to storage. And when I say storage, I mean object storage, storing files, storing images, videos, etc. So we're not talking about databases, because databases, that is a whole nother beast that we will delve into. But when it comes to storage, there's really three big options on GCP. There's cloud storage, right? So this is unified object storage. This is what you're going to typically use if you say, oh, I need an image library. There's persistent disk. So this is when you're attaching a disk to a compute engine instance, like it can be a VM or a Kubernetes. So this can be more efficient. So if I have a VM that is serving a bunch of images, I might want to do it this way as opposed to having cloud storage. The persistent disk, if it's an SSD, it's just going to be quicker and actually attach directly to that machine virtually. And then finally, cloud file store. So this is basically what amounts to network attached storage. So this is sort of like I can have a pretty simple native experience for what looks like a regular native network attached storage, except all that stuff is being stored in the cloud. So instead of it in my data center, I can put that in the cloud. So that's pretty much it. This is kind of, there's options for this. This is, similar to S3 in Amazon, but those are kind of the options that are presented in GCP. All right, so now I'm going to get into some of the real meaty stuff. So databases and analytics. This has been, I would say, in the last 5 years, if you look at that graph, this has been where really the majority of innovation has taken place, in my opinion, with maybe machine learning and some of those things also there. But it's certainly been the one where companies have gotten the most use out of it, because these are all very fully baked and they're very applicable to almost any application. And that's why it's so significant that we've seen this kind of revolution in the way that data is able to be stored and accessed. So let's take a look at these. The first one is called Cloud Spanner. So if you haven't heard of this, this is like SQL on super duper steroids. This is a mission critical, scalable relational database that has an absolute global scale. So if you've dealt with SQL before, you know that, hey, it's great for relational stuff, but if I try and have it serving requests to Japan, Egypt, Europe, and the United States all at the same time, that becomes really complicated. And I'll probably have to stand up local clusters to be able to do that, and all of these different things that you have to do in order to be able to serve global scale customers. Cloud Spanner does that for you. So it manages a lot of these things. It's still relational, but it allows you to have massively scalable applications. Cloud SQL, so this is just your typical SQL, and you can use Postgres, MySQL, and now SQL Server. So this was a hugely requested feature, and one of the things that Google didn't have for a long time, but now you can actually deploy standard Microsoft SQL servers into Cloud SQL. Cloud Bigtable. So this is another one of those Google scale, petabyte scale for a fully managed NoSQL. So If you think of Spanner being their super duper global thing for relational, think of Bigtable as the super duper big thing for non-relational. So this is, you have huge workloads. It has been said that Google search itself uses Bigtable. So if you think about that as kind of your, oh, okay, right? It's an application. It has a ton of unstructured data in it, and it needs to respond in sort of these millisecond. It has to get back to customers really, really fast. That's the type of applications that Cloud Bigtable would be used for. Cloud Data Store. So this is a highly scalable, again, no SQL database for web and mobile applications. So this is if you just want that SQL type storage, but you don't need it to be relational, and you want to pick up some speed instead, it's a good choice for that. Another NoSQL database is Cloud Firestore. So this comes from the Firebase product. So it is used specifically for mobile and web applications. It's just another option that they have available. Similarly, the Firebase real-time database is one where if you need data in real time, so you're building a multi-user game that is going to run on mobile applications, really good for that kind of data that is moving between devices in real time. And then finally, Cloud Memory Store. So this is an in-memory service. So it's compatible. It's basically Google's implementation of Redis. So if you're familiar with Redis, that's what this is. You need to be able to read memory and read at incredibly quick responses to be fetching information as the application needs it. Use Cloud Memory Store. So that is an overview of the databases. This is a pretty cool graph here, and I'm not going to go through every one of these options here, but one of the most important things in databases is just to choose the right one. I mean, it used to be that maybe you had two options. You said, well, I'm looking at SQL or maybe this other one, maybe an Oracle one or something. And now you just have so many options, and we haven't even gotten to the analytics ones, right? These are only if you're looking at really structured or relational data. And then you have the no structured ones as well that are specifically needing these like really fast response times. Well, what's nice is you can kind of go through this and say, okay, Cloud SQL, yes, it's okay if it's zonal, I don't really need it to be global. Yep, it's got my strong replica consistency. Okay, it's also got ultra low latency. Okay, that's all I need. This would be a good choice for me. But there's also many other considerations, and we often go through with customers. We spend a good deal of time really making sure we're making the right decisions when it comes to this type of thing. So just like choosing the right VM or choosing the right containers, choosing the right databases and where to store this stuff if you're migrating data. Most people are not like starting a company and then they say, oh, I think I'll start collecting data today. Most people have way more data than they know what to do with, or they haven't even begun to process all this data, and it's just sitting there on servers, and it's not giving them any insights or any things. And a lot of developers now are getting jobs because companies are like, hey, come on in and look at our data. I need you to process our data, the stuff that we have on our customers or on our sales stuff, and give us insights on that. That's a huge field right now that's just exploding, and that goes into can you use machine learning on our data? Could you give us some predictive insights about what that data is? And a ton of that process is all about choosing the right database. Because if you're not storing that data in the right way or in the right place, machine learning becomes super duper difficult. It becomes nearly impossible because you're going to have to move that over to a database that machine learning products can interact with. So that's an example of where these low-level decisions really, really matter when you're architecting your application, all based on use case. Okay, so data analytics, and this is actually more along the lines of machine learning. So the things that you'll see in here are much more often used as the backends for machine learning, simply because of the way they're designed to be these just massive piles of information that can be quickly read through and analyzed. So the first one is BigQuery. This is probably my favorite because, and it really is the only analytical database. So BigQuery is often referred to as a database. It almost belongs in the previous slide. But Google actually puts it in this category of data analytics because it is so specifically suited for doing analysis. So it is a serverless, highly scalable data warehouse. And when I say highly scalable, we're talking petabyte scale stuff. You can do a query on BigQuery not across millions of rows, but across billions of rows and get an answer back within a second. That was impossible 5 years ago. So the fact that now you can select something like BigQuery and say, okay, I have data on like every single transaction my company has ever done, name, place, location, and I want to say, well, show me how many transactions I did on this date. And it comes back to you like that. 387 or whatever the query is. That was an incredibly difficult computer challenge and an incredibly challenge for application folks who would have to divide up the data. Very often they would say, well, it's too big. We can't store it all in this SQL database. So let's make different SQL databases for, we'll put the customer data in this one, and we'll separate those tables, and we'll put the thing over here. And then you ended up with like hundreds of tables and hundreds of databases, and you're doing these extremely complex joins to get an answer on anything. And you've all done it, right? We've all written, if anybody who's done data analytics, you've written a join statement that would like blow your mind. You look at it now, you still have no idea how it works, but it does. And so BigQuery is kind of the backlash against that and say, no, don't do that. Just take all your data and throw it in there. Just put everything into BigQuery because it can store billions of rows. Just put all the stuff in there, and then we won't charge you for that. We're only going to charge you when you actually use it. So that's another really unique thing about BigQuery, is that not only is it serverless, so there's nothing to manage, there's no infrastructure to manage, it's just going to scale as you use it, but it doesn't really charge you for any of that storage. It's infinitesimal amounts. What it really charges you for is when you actually create the query and say, okay, show me this data. And that is really appealing to a developer who says, okay, well, I don't have to spin up Redshift servers or get all this stuff ready to go at first. Redshift being something that Amazon has, right, where it's still a really cool product, but you have a lot of things that you have to do before you can get started. You have to spin up and manage these infrastructure pieces. Where that's not the case with BigQuery, you can just start populating rows, just start throwing data at it. And so then you have this nice database where it's got all this stuff, and you can just start querying across it, and you get these results in incredible amounts, very, very quickly on a huge amount of data. So it's great for all the other things that I'm going to talk about. A lot of times BigQuery is sort of the workhorse for these other things on this data analytics page. So I'm going to go through these a little quicker because there's a bunch of them, but they do very similar things. Cloud Data Flow is Apache Beam, essentially. So Apache Beam in the cloud. And it's a fully managed service for transforming the data. And you can do it in stream or in batch. So often, let's say I have drones that are flying around and they're picking up telemetry data. And I have that telemetry data from the drone. It's not going to be very readable because it's going to be a million numbers, and I may want to do something to that. I may want to convert it into standard format or convert it into coordinates or a zip code or something like that. So if I need to convert that data that's coming in, whether it's coming in real time or in batches, I can use data flow for that. And I can programmatically say, whenever I see this pattern in the data, I want you to translate that into this. So, you can standardize birthday and date formats, all that different stuff that you have to do when you clean data. That's what data flow is for. Data prep does the exact same thing as data flow, but it allows you to do it visually. So if you're not a coder and you would rather say, I want to actually construct it, if you're familiar with macros in Excel, it's almost very similar to that. So you can visually go through and say, okay, whenever I see this, I'm going to click on this type of data, and I'm going to convert it into this. So I'm going to convert this into the metric system as an example. And then it saves all those rules and actually creates Apache Beam code out of it. So it actually does the same thing in the end, but it allows you to do it in a very visual way. Cloud Data Proc. So this is just managed Apache Spark and Apache Hadoop. So if you've got Hadoop or Spark today, this is a way that you can move those services to GCP. PubSub, so pretty similar. It's global messaging. So if you've used the PubSub format before, it's the cloud implementation for PubSub. Cloud Data Lab. This one is actually pretty cool. It's kind of hard to describe exactly what it is, but it's kind of like a console or a shell. So think about being inside of this shell where you can type out commands to Data Lab. It's very interactive, and it actually allows you to build machine learning models and do analysis in real time. It's fantastic in the education space. If you do anything, if you're in college or you're a professor, it's awesome for that because you can put the students in front of it and you can literally type out the commands for building a machine learning model, and it'll do it on the fly and actually show you the results right there in the same window. It can build graphs and it will show you the graph, and it saves everything that you do to this Cloud Data Lab, so that you can go back and see, oh, what were the commands that I typed? What did I actually work on there? It's a really cool tool, and it's great for anybody that's doing machine learning or wants to look at doing analysis and visualization. Genomics. So Google has its own genomics platform for running things that are around medical research. Cloud Composer, so this is Google's implementation of Apache Airflow. So another way, it's a way to do workflow orchestration. And finally, the Cloud Data, actually there might be one more here, the Cloud Data Catalog. So this is a way that you can take all the data that you have on GCP and catalog it and pull the metadata out of it and basically create your own little Google search of your data using this service. So it could pull out all the metadata, all the text that's in there, all of those different things, and make a searchable database that you can then create an application that can consume. And finally, Cloud Data Fusion. So this is, again, one of Google's big pushes, and I would say really everybody is trying to do this, is to try and bring machine learning and data analysis to the masses. Because as awesome as Cloud Data Flow is, you really have to know the underlying code to really get it to work well, right? You have to know exactly how to code, how to translate something from this column to this column. And if you don't know that, then it's really hard to get started in some of these things. So Cloud Data Fusion, remember how Data Prep was the visual version of Data Flow? Cloud Data Fusion is sort of the visual version where this says visual point and click interface that enables code-free development of ETL pipelines. So it's kind of the full visual version of both of these. Kind of takes it one step further and says, I want to be able to actually take data and take these 3 columns and move it to this part of the cloud, and then clean it in this way and move it to this part of the cloud. And you can see all those pipelines working together. So to have a visual representation of what is happening to your data and where it's going is pretty cool. It's also great for, say, executive managers that maybe don't know what you're doing with the data, and you want to be able to create and show these really nice diagrams to be able to say, hey, here's what we're doing with our marketing data. This is actually what's happening to it. You're looking at not only a graph, but it's actually the code that is being performed on this data. All right, so the final piece that I'm going to talk about today is machine learning. So this is a lot of this has been building to machine learning. And before I get into machine learning, I want to say that it's definitely a hot topic, right? If you've been around the cloud at all, you've heard this thrown around a ton. And what's interesting is machine learning is actually not new at all. It's actually probably 50 plus years old. At least the idea of taking data, giving a computer a specific instruction set to say, look at this data and find patterns, and then bring me back what you found. that concept has been out in computers for a long, long time. The reason why it is in everybody's mind today is because what we're seeing now with the cloud is that I don't have to have Stanford or MIT's supercomputer to do this. I can do this at home. And if I have enough money as a company, I can do this on the cloud without buying any of my infrastructure. So because of the infrastructure revolution, there has been a resurgence in machine learning. So it's not necessarily that the techniques or the ideas have changed all that much. It's that now that it's possible, right? So it's almost like when there's new telescopes that are seeing things in space. They've always been there, but we just couldn't see them. We couldn't get there because the technology and the raw power to be able to do this type of stuff wasn't available. Well, now I can throw 1,000 TPUs at a problem and get an answer back in 10 minutes that would have taken 10 years, right? So now all of a sudden these problems that would just take an unbelievable amount of computing power are fully available at our fingertips. So this is a little bit of a daunting slide, but I think it's important to think about machine learning as it is an overarching term, but by itself, it doesn't actually mean much. And most developers that are in ML will say that it's very use case specific. So it's kind of like the running joke is that an executive will come in and say, hey, here's a set of data. I want you to run machine learning on it and tell me all the things that it tells you. And that's not actually practical. That's because we don't know what it's going to tell us unless we're asking the questions. So machine learning is really much more useful if you said, here's my financial data. I want you to tell me in the next 6 months, what the trend line is going to be. Something like that, right? To give it parameters. One of the biggest common mistakes in machine learning is that there isn't enough parameters around the question. So you're trying to do these very generalized application. I mean, a perfect example is the weather, right? There's so many factors in the weather. That's why they don't always get it right. They can guess and they can look at these models, but it has a million factors. So it's actually a very incredibly difficult machine learning problem to get right. Same thing in business or in any of these problems. The more factors that you're trying to put into a problem, the less specific and the less useful your answer is going to be. So with that framework, that's why you see these different services kind of divided up in these different ways. So what I have here is I've kind of created this, this hierarchy. On the very left is what I refer to as general ML. So this is if you have your own project, it does not really fit into any of these predefined use case stuff that you see in all these other boxes. So most projects that are going to be around business use cases will, and when I say business use cases, I mean the business themselves is creating the machine learning question that they want to solve for. That's why you have to kind of start with, okay, I'm going to use cloud TPUs. I'm going to create my own TensorFlow application. I have to create those tensors. I have to do all of that heavy machine learning stuff. So there's cloud TPUs. There's also something called AI platform, which is sort of similar to Kubernetes platform. If you think about it, it's a managed way to do the machine learning. So I can spin up, like I was mentioning before, if I wanted to spin up 100 different servers, or if I wanted to, really increase the calculation, I can use AI platform to really manage how the machine learning jobs are run. So that's general ML. Really, everything else falls into some form of specific ML. So I look at AI services, right? If I want to create a recommendations engine, great, I've got an AI for that. But again, that's very specific. I've got some kind of recommendation engine that I want to do, but that's only if I'm doing that particular use case. Same thing with this. I want to do data labeling, right? I've got I've got pictures, and I want to say which ones are birds or which ones are this amount of data or whatever. It's the same kind of thing. It's a very specific use case. And you see these in these ML APIs as well. Now, what's cool about the APIs is, and by the way, as you move left to right, this is most amount of work to least amount of work as far as setup. So these APIs, what's cool is they're pre-built, right? So this Cloud Vision API, this would take you an unbelievable amount of time to build yourself. What the Cloud Vision API does is it essentially recognizes objects, and it can recognize things about those objects. So if I fed it a picture of a man wearing a red hat, it would tell me man, middle-aged maybe, red hat, and it would pull out all these things. And then I can use that metadata to make the image searchable, to maybe I'm looking for my brand logo in different pictures and I want to pull out that logo, anything I want. So, and you can train the API to find specific images and then have your images. So that's an example. But again, it's only really applicable if you're doing vision, or if you're doing that same thing, speech to text, text to speech. This one it does the same thing for video, inferences, natural language, and translation. So you can see that these are really powerful APIs that are pre-built, they are pre-trained, they already kind of have all those things in there, but whether or not you can use them really depends on whether or not your use case fits into that specific category. Now this is a fairly new thing. I would say in the last couple of years, Google came out with something called AutoML. And this is an even more interesting version of these APIs up here. So what a lot of customers were saying was, hey, I have this Cloud Vision API, right? I get these certain things back from these pictures, but what I want is different results back. So AutoML Vision is a way to create your own model, but still use kind of the pre-trained stuff that Google has already built. So a good example would be, for instance, you want it to train to recognize a specific person's face, right? So Cloud Vision API is not going to know that, hey, this is Greg's face. It will just say it's a man, right? But that's not specific enough for your use case. So you want to be able to train it. So I could feed it a bunch of pictures of my face and then train it to do that. And now I can use that API to actually say, oh yes, it's 92% probable that this is actually Greg. So that's really cool. I don't have to go all the way over to the left here and build my own TensorFlow project to do that. I can actually use AutoML to do that. So I'm given a little bit more flexibility with all of these. So you can think about all these in kind of the same way, right? Translation, I can add in my own translation terms. I can add in words that it never gets right. Those kind of things. So it really opens up some interesting things. And the most interesting thing in here is this very, very new one called AutoML tables. And this is kind of the first thing that's trying to generalize these use cases. So I've mentioned, you can see that these are very specific use cases, but AutoML tables is that very first one that using, say, a BigQuery table. Let's say I have this BigQuery table. I could take it and say, I want a machine learning model running against that table. You can use this service to do that. And you don't have to set up any of your AI platforms or run TPUs or anything because the training is already there. So it has all these pre-built models. It can recognize what a financial model looks like. It knows what some of these spending models or a usage model, or this is an estimator for shipping costs, whatever it is. It kind of has a lot of these things built into it from all the data that has been gathered on these types of use cases. So this one promises to be a little bit different in that it might finally open up more to the general public, this idea that, hey, maybe I don't have to build and train my own model. I just need to collect really good data and put it all in the same place. And if I can do that, then I can actually use the cloud to do machine learning without being a machine learning expert. Because there's a huge shortage of true machine learning experts. They're rocket scientists, right? They're very difficult to find, but there's a lot of developers. Nothing against developers. Developers are awesome, but we all know, we're not all machine learning experts. So because of that, Google is really trying hard to bring that power of machine learning to developers that can utilize it. So that is my overview of Google Cloud. I'm going to leave you with this last slide that I have here, which is a sample GCP architecture for Google Cloud. So, I've been talking about all these different things. How do they fit together? How would a project actually look in Google Cloud? It might look something like this. So this is one that was built for an IoT, so an Internet of Things, a sensor stream system. So let's say you had air conditioners in server rooms that needed to be kept under a certain temperature, and it's constantly feeding. These devices are feeding the temperature, right? 40 degrees, 41 degrees, 40 degrees, and it's sending it into your monitoring. So you might use Cloud Pub Sub to push that to Cloud Data Flow, where you would say, okay, Data Flow is going to change those into standard numbers, because sometimes it will say 40.0001. I'm just going to chop that off and make it into a regular number. Then I'm going to store those normalized data sets into one of my data tables here. Let's say I use cloud storage, because I don't really need millisecond response per se. And then I'm going to build an app on top of it, right? I might build a Kubernetes Engine application that is going to show me in my, on my screen, I can go to and look at all of these different temperatures, the last minute or so of these temperatures. And then I can have this analytics piece too, so I could look at maybe over time, I could store everything into BigQuery, and over time I could see, hey, is there one of these that consistently gets hotter? Could I potentially predict a failure on one of those, doing something else later on? But I'll have all of the historical temperature data and failure data, stored in one place using BigQuery. So again, just a sample application of what you could do, and this is the kind of stuff that we do at my company all the time. Is we're building out these pretty complex but very seamless architectures for companies who really want to solve some of these problems. Things that were very, very difficult to do just using on-prem stuff suddenly become very possible to do with the cloud. So I hope you've seen some of the services today. Google Cloud Platform started out very small in 2014, but it has really, really matured in the last 5 years, and it's really grown into something that is used by all kinds of businesses. Some of the biggest companies in the world use Google Cloud Platform for their key mission critical services. So I hope you got some overview from this and learned something from the presentation. I want to thank everybody for joining. Once again, my name is Greg Heier, and I'm with Onyx, and there's my contact info if you'd like to reach out. I'm happy to talk to you or take any questions that you would have through those mediums. So thanks again for your time.
Thank you very much, Greg. It's a great presentation. Let me see if we have. Yeah. There's one question says, thanks. Google entered the cloud market later than Amazon, AWS, and MS Azure. What's the advantage of GCP over the other two?
Yeah, it's a great question. They definitely did. I would say they entered the market later, but they actually were first to building the infrastructure that you get to use. So if you remember those 9 applications, Google Search has been around since 1999, and many of those applications were around much earlier. So the actual underlying application and all of the lessons learned and all of the infrastructure that they've built, their own fiber lines, all that stuff, that's been around. They just took a while to actually open it up for companies and say, hey, you can use the same stuff that we do. So that's kind of the difference between Google. They certainly have a long way to go when it comes to capturing market share and some of that stuff. But as far as the infrastructure goes, it really is top notch. Now, as far as like which one to use, it comes down to personal choice. We actually work with all 3 of those major clouds at my company. So sometimes the right choice depends on that use case. So it might be, hey, we've got a great use case. It's perfect for BigQuery. And that's a GCP specific application. So let's run it there. There might be another one that's, hey, this is a really good fit for S3 because of XYZ factors. So it'd be nice to say, oh yeah, this is, this cloud is the right choice for everything. But typically because of existing infrastructure and because of existing things in place, maybe a migration isn't the right choice at that point in time. And again, I think you're going to see this sort of combination with things like Anthos and others. You'll continue to see certain use cases use this cloud and certain use cases use another one.
Well, would you be able to like give an example and say what kind of use case is good for, say, Azure, and the other one maybe a good use case for GCP or even AWS?
Sure. So, like, if you are a lot of companies, they grew up as a Microsoft shop, and you have some really heavy investment in the Microsoft servers. Those Azure servers are super tempting, and they're a really good option because you won't have to retrain your staff. They know a lot of those commands. You can move servers much more seamlessly, specifically from that environment over to Azure. Now, there's obviously other considerations or complications, but again, for those heavy Microsoft only shops, I think that we've seen that they've chosen that as a really good option. As far as Amazon goes, Amazon has a really good, they've got really good global presence as well, and Google does too. But if I want a application that is going to like run on VMs, and I want to run them in very specific zones, AWS might be good for that. So from the maps that I showed you today, I think Amazon has many more data centers. So I could say, I really want to run this specifically in Singapore, and I want to run it right here, and that's kind of my global region. So it's really good for regionalizing and that sort of thing. So those would be kind of my two, and then maybe the one I would do for Google is the petabyte scale BigQuery, something like that. That's a pretty good GCP use case. Is I've got petabytes of data and I want to do analysis on it. Like I've got 50 years of weather data and I want to see a trend in it. Just dump it all into one single place, and I only have to pay when I actually run a query on it. BigQuery is a really good use case for that.
In your sample GCP architecture, you mentioned gateway. Well, in that example, does everything go through the same gateway, or just you just use one as an example here?
Yeah, this is just an example. So this is sort of representing the firewall, virtual firewall that you would build that would come through, right? That you would want to filter things out. So you've got your devices that may be spread out all over the place, and you're going to run some sort of gateway service that is going to say, hey, is this a legitimate call into my application, or is this somebody trying to hammer my application for like a DDoS kind of thing? So those are, and again, yeah, you can create a different architecture based on where those devices may be. This was just one example of that.
Okay. Would you be able to show something about the Google Data Studio? And most importantly, I'm kind of interested in the fee structure
for Data Studio.
Uh-huh.
So yeah, so we didn't talk about Data Studio, but it's actually technically in the G Suite or kind of in its own application, but it is also it runs on the Google Cloud, but it is a really cool application. It is it's sort of a fully graphical interface, drag and drop to do your own graphing and your own analytics. So it has a really slick interface for that. I don't have anything queued up to show here, but I can talk a little bit about the cost structure for sure. So basically, you can click on buttons, you drag a graph, and you can boom it just creates a graph on the screen, and then you can select, okay, I want this data source and I want it to show this. Essentially, everything that you could do with Excel, where you could create graphs out of the Excel, think about taking all of that out of Excel and making your own like nice formatted web page to actually show those statistics that updates in real time and all this stuff. So it's great for that, and it's really great for any size business can use it, and it runs the same sort of thing. I can hook it into a BigQuery database, and I can make graphs that are actually going across billions of rows to do that. Now, as far as costing, it does, so by default, it's actually free. So you can access it yourself today. If you go to Data Studio, I think it's just datastudio.google.com, you can go and access it for free. The costs then are really only based on your data. So again, if I'm in BigQuery and I'm running queries against that data, that would incur costs against my BigQuery database. But if I'm running like an SQL database and it's only, being charged a couple dollars a month or whatever the cost might be, it's probably going to be negligible for what it's actually querying against. So it all kind of depends on the data structure, but the nice thing is there's no upfront cost to start using it.
So basically, the cost comes from the source data. Is that right?
Yes, that's kind of right. But the good thing is that Data Studio is actually really intelligent about how it does queries. So it's not like a website where every single time that you load it, it goes out and queries all the data and brings all the stuff back in. It has really intelligent caching, so it will cache to the users. And it only goes out, you can actually set the frequency, but it can only go out like every 4 hours, for example, so that you're not getting constant hits across it. But that's some of the things that you can actually customize inside of Data Studio. We have several that are running against a billion row BigQuery, and the costs are actually pretty negligible because of the way that it really intelligently handles the queries.
Is that possible to set up like how often you want the report built by Data Studio to refresh the data?
Yeah, so right, I'm trying to remember because I know that some of that is dependent on the data source. So some sources will allow you to do it more often. You can always click refresh on the interface to force a refresh. So it kind of does and I can't remember what the default is. It might be 4 or 8 hours. It'll default refresh that data. But if you say, okay, I've got a presentation to my management, I can just click refresh and make sure that I have a fresh set of data when I get there.
Okay. Well, continue with this topic. Is that similar to, say, like a Tableau or Power BI? Or what's the difference between this one?
So yeah, great question. The output is similar. So if I think of Tableau, I get to build these wonderful websites, and they've got all the data there. That's great, and the output is awesome. The difference is that Data Studio is much more. It really empowers the user to build their own stuff. So you couldn't really hand Tableau to a business user and say, hey, go build something on this, because what you would find out is you have to set up a server, and you got to set up a web server, and then you have to run Tableau on that web server, and then you've got to learn the Tableau like all the management queues and all that stuff behind that. So Data Studio's response is sort of like, well, instead of all that, this is going to be more like, if you're familiar with Google Sites, it's kind of the same sort of thing. Like, instead of having a web server that you have to set up and do all these things just to create a website, What if you could just go in and drag and drop your components and set them up where you want and say, I'm done? And so that's kind of the real appeal, is that managers are very, very interested in creating their own analytics and not having to have to go out to an analytics department to ask for those, but to really be able to set up their own dashboards the way that they want. And Data Studio, while I wouldn't say it's like completely intuitive, easy for everybody, because you do have to understand a little bit about data types and setup. It's far more accessible than any other like data analytics that I've seen.
Sounds good. Here's another question from the audience. Since you have experience with all three cloud services, who has the best customer services? And
that question could have been worded many different ways. I mean, I've dealt with all of them, and they really all have been really responsive to us. So that is obviously a very difficult question to kind of ask, and many of them have services as well, right? So Google and Microsoft, I know for a fact, like you can set yourself up with specific services. So you can say, for this application, I want this level of service, which you would pay for, and then you can make sure that you've got a person that you can call. You can get your own managers, and that's actually something that we will augment as well. So many times partners will augment that too, where they'll say, hey, I want 24/7 support, on this particular application. If it goes down or something happens, I want somebody monitoring it, and I want somebody calling me. That's where partners can really step in and help those big cloud providers, which, sometimes they don't have the greatest reputation for what they do on the customer service side. And that's been something where they've really relied on some of the partner systems to scale that out.
Yeah, makes sense. This other question is, appreciate the information you provided, and could you provide some insight into how small and medium businesses can utilize GCP to expedite business growth? What would be the challenges and opportunities?
Yeah, great question. I actually think when Google started, that was their core. It still is their core. They certainly love that big enterprises are starting to use Google Cloud, but the small and medium is their sweet spot. It's awesome for them because I would say the number one reason is because of cost. Is that if I'm a medium business today, my competitors are the big boys. They're huge guys that have their own data centers, and historically they've been able to just crush me by throwing more trucks on the road or just throwing more data at a problem. But what I can do now is I can do some of the same exact things, at least computationally, that these bigger players can do. So I can take my marketing data and run it through these marketing engines just like they can. I can store all of my data for my entire company for pennies on the dollar, and I don't have to spend anything else. Startups, especially, some of the disruption that we've seen across Silicon Valley is only possible because of the cloud. If I had to, we'll take Snapchat as an example. So Snapchat runs entirely on Google Cloud Platform, and they pay a crazy tiny number comparatively for a billion user application. There's no way they would have been able to get to a billion users without incurring a tremendous amount of debt. And the reason is they were able to scale just as they scaled their users. So they didn't have to invest infrastructure, and the application didn't go down a bunch as they were trying to scale up. We all sort of remember what happened with AOL when everybody was trying to get online, and all of a sudden there were no circuits left. And they didn't know, well, do we scale up a ton? And they tried to do that, and where do we scale it? All of that stuff. So there's tremendous opportunity for disruption for the small kind of the startup businesses and the medium businesses, in the sense they can use all that computational power, and they can also do these things that massive computational power that typically would take like a Facebook level entity or something like that to actually accomplish.
Wow. Okay. So you talked about the data analytics part, and is there a cost to use the data analytics, or it's kind of free?
So there are costs on those analytic tools. Data Studio is the only one that's free. The other ones do have costs when you actually like implement the code. So like data flow, for example, I can go into data flow and like program all that stuff, but when I actually press, hey, execute the code, that's when it would charge me. Because essentially what it does is it spins up some server microarchitecture servers, runs the code, and then spins it down. So it might cost you a few cents here and there. Now, obviously, bigger projects is going to cost you more. Cost management and how to do that sort of stuff on the cloud is definitely its own subject matter in itself. But yeah, there's incremental costs for most of that data analysis stuff, except Data Studio tends to be a really good free one. And one thing about Data Studio is you can actually hook it into just like Sheets as well, or some of those things where those are also free. So you can actually do sort of more. It's a little bit more lightweight than a billion rows, but you could do a decent analysis on stuff without incurring costs.
When you say Sheets, is that something similar like Excel kind of files?
Yes. So Google Sheets is the cloud-based version of Excel that is inside of G Suite.
Right. Okay. So it has to be Google Sheets?
There's actually a ton of connectors for Data Studio. I don't know if they have one for Excel, but they might already. They've got Salesforce and all these other ones. So the Salesforce connector is not going to incur any costs, because if you pay for the Salesforce Enterprise where you have the API, all of those are sort of built in. So many of the applications that people use today that they want to tap into and do analytics, there are native connectors for inside of Data Studio. So all of those wouldn't cost you anything extra.
Oh, wow, that's great. Okay, one last question. Is there is it possible to use a graph database in GCP?
Was it a graph database?
Right.
Well, yeah. I mean, if we're talking about Data Studio, like doing graphs and like bar charts, that sort of thing.
I was more thinking.
Or is this a type? I'm sorry. Is this a type of database called a graph database?
Yeah. Right. Yeah, the type of database, instead of say like a SQL Server, and we do graphs. SQL Server is more like like relational database, right? And then there are some that now I kind of forget the name of the graph database, but yeah, I was thinking whether or not we can use
I see. Yeah. Okay. Sorry. I was still thinking the Data Studio stuff. You're talking about the graph database type. I don't know if they have a managed version of that where they do have graph databases, but that's something that I'd have to look into. I know that it's some of it is just about the type of database that it is. They have a lot of different types. They really focus on those relational or the non-relational when it comes to the database types. So I'd have to see if they had anything, but as far as I know, I don't think they have anything that's managed on that.
Oh, okay. Sounds good. I guess that's all we have. Yeah, this video is this session is recorded, and I'll try to post it on our website by tomorrow. And Greg, if you could share the slides, I'll post the slides to our website so that whoever want to review it or didn't get a chance to join our webinar, they can watch the video and also have a copy of your slides.
Okay.
Thank you so much for a great presentation tonight. I did learn a lot, even though I went to a GCP Google Cloud presentation before, but I still learned quite a bit from you. Thank you so much. I really appreciate that, and I think everybody thinks the same. And from the people, our audience recording them, many says thanks already.
Okay, well, thank you so much for having me. I appreciate it. Thank you.
Thank you, and thanks to everybody for attend this meeting, and then hopefully we'll meet next month. Thank you, and we'll see you next time. Bye.